people. Systems of equations by substitution, part A. Here's going to be our steps. Isolate, substitute, solve, substitute again, solve again. Okay? Now we already dealt with this topic. In topic number 20, we were solving systems by graphing. Okay? Solving by graphing still works, even with these. Remember, the issue with solving by graphing, though, is if we're imprecise with our graphs, if we don't make perfectly straight lines, we don't perfectly place our points, it's possible that we get wrong answers when we're graphing, especially by hand. Okay? Now, the other issue with solving by graphing is when you move on to later in the year, Algebra 1, definitely into Algebra 2, we're going to want to be able to solve systems that have more than two variables, right? And you can't easily graph 3, 4, 5, 6 different variables, okay? So we're going to look at an algebraic way to solve these. Splitting this lesson into two parts. First part, we're not going to worry about isolation. All right, so I'm already going to isolate a variable for you. Your job is just going to be to identify which variable is isolated. Isolate means get by itself. Here's the variable that's already isolated, x. In the second equation, x equals this. Okay? So, identify your isolated variable. Next step, substitute. Substitute means replace. Right? And what I'm going to do is replace x in my first equation with this. All right, 4y minus 15. Now, why am I allowed to replace that? Because 4y minus 15 equals x. All right, I'm not replacing it with a different value. 4y minus 15 equals x. Okay, so this is what I'm doing. Rewrite this equation. 3, and instead of writing x, I'm going to write this. All right, but before I do that, let me continue. 3 times x minus 2 times y equals 15. All right, so I've rewritten this top equation. 3 times x minus 2 times y equals 15. Okay, see that I've just rewritten that. Now again, I'm going to replace x with what x equals. So 4y minus 15. Okay? That's all that I've done. Replace x in the first equation, 4y minus 15. All right, now, solve. You've already dealt with these. Actually, you don't even need skill 34. You dealt with this in skill 24 because all my y's are on one side of the equation. Okay? So, back to skill 24 if you need to review. We distribute, combine like terms, opposite operations. All right, distribute. 3 times 4 is 12. 3 times 15 is 45. All right, distribute, combine like terms. 12y's minus 2y's is 10y's. Okay, opposite operations. Add 45 to both sides. 10y's equals 60. Divide both sides by 10. Y equals 6. Cool. Feel like I'm done, but I'm not. All right, so we located our isolated variable, substituted, solved for y. Now we got 2 more steps. Substitute again, solve again. This time it's a little easier though. Now that I know what y is, I'm going to substitute in y value, 6, right here. Okay? I know now that y equals 6. So, x equals 4 times y minus 15. All right, I'm rewriting my second equation. And instead of writing y, I'm going to write what y equals, 6. All right, 4 times 6 is 24, minus 15 is 9. X is 9, y is 6. Now, I already know that they solved the second equation. I can use, if I want to check, I can test them in my first equation. 3 times 9 minus 2 times 6. Does that equal 15? Okay, you grab a calculator, type that in there. 3 times 9 minus 2 times 6. Okay? So I solved for x and I solved for y, right? That's how it works. That's the whole process. Now, you can hit pause and see if you can do this, or you can watch another one before you decide to do it on your own. Step 1. Find the isolated variable. Okay, I'll put it in the same spot. It won't always be in the lower left, but v is isolated. Step 2, substitute for the other v. Okay, I'm going to replace v in the first equation with what v equals. So we have w, first equation, plus 3 times v equals 7. But I'm replacing v with 2w plus 21. Okay? Isolate, substitute, solve. Distribute, combine. Opposite operations. All right, distribute. W. Remember, W is the same as 1W. I might want to write that for later. 3 times 2 is 6 W's. 3 times 21 is 63. Combine like terms. 7 W's. Opposite operations. Subtract 63 from both sides, we get 7 W's equals negative 56. Divide by 7 on both sides, W equals negative 8. Halfway done. I'm going to substitute again. This time, I'm going to use negative 8 in place of W here. So we got V equals 2 times W plus 21. Negative 16 plus 21 is 5. W is negative 8, V is 5. All right? 2 times negative 8 plus 21, 5. 3 times 5, 15, plus negative 8, 7. All right? W equals negative 8, V equals 5 are the two values that solve both equations. That's the solution to the system.